everyone. Today we are exploring electrical connectors in product design. Connectors are vital components in electronics, automotive and industrial applications, allowing devices to communicate and transfer power reliably. Let's dive into the basics of connectors and their engineering importance. What is a connector? An electrical connector is a device that joins electrical circuits, allowing powers and signals to pass through. Connectors provide mechanical and electrical stability, ensuring secure connections. These are used in consumer electronics, automotive wiring harness, aerospace systems, and industrial automation. These are designed to be removable or permanent based on the application needs. For example, USB versus automotive connectors. A USB connector is designed for easy plugging and unplugging, while automotive connectors must withstand vibrations and temperature variations. Types of electrical connectors. Wire-to-wire connectors. These are used in automotive wiring harnesses. Wire-to-board connectors, found in circuit boards and microcontrollers. Board-to-board connectors, used in high-speed electronics like laptops and mobile phones. Circular versus rectangular connectors. Circular connectors are rugged and used in military applications, while rectangular connectors are common in consumer electronics. Let us take an example. Automotive wiring harness connectors. These are designed for weather resistance, vibration-proof locking mechanisms, and durability. What could be the key considerations on designing these connectors? First, like usual, material selection. High conductivity metals like copper, gold-plated contacts for high-performance applications. Next, connector housing must be heat-resistant, impact-resistant, and lightweight, made of thermoplastic like PA, grade could be PA66. Pin configuration and contact points. These defines how signals or powers are transmitted between components. Environmental resistance. This could be waterproof, corrosion resistance for industrial and automotive use. For example, aerospace connectors must withstand high temperatures, pressure variations, and electromagnetic interference (EMI). Now, let us get into these best practices for connector design. First thing, one should ensure high reliability with gold-plated or corrosion-resistant contacts. One should optimize connector size based on the space constraints in the device. The design locking mechanisms for secure mating in high vibration environments. One should test for electrical integrity, durability, and thermal stability. And that's an overview of electrical connectors in product design. Whether in automotive, aerospace, consumer electronics, connectors play a very crucial role in ensuring seamless power and data transfer. Stay tuned for more engineering insights.